Good afternoon, learners. My name is Gishingili Kamwelo, and I teach drawing and design at the Moi Forces Academy in Nairobi. Today, we are going to learn about equal areas. Equal areas are important in the calculation of areas, land surveying, or branches of engineering that requires service space planning. Examples are in urban planning and also in architecture. And we are going to learn through this lesson the construction methods to construct a triangle equal in area to a given pentagon. We are also going to draw an a rectangle equal in area to that triangle, and also a square equal in area to the rectangle. So we are going to start by the construction of a pentagon. Let's have the side of the pentagon as 3 centimeters. The method that we are going to use is the universal method. So bisect line AB, so draw angles of 45 degrees and angles of 60 from the center point of the line AB. Taking that radius, we can get an angle of 45 degrees. And if you take the entire length of AB, we can be able to get an angle of 60 degrees. When we bisect the difference, at the end of that arc of 45 degrees, we write 4, and at the end of the arc for 60 degrees, we write 6. So we try to locate the point 5 by bisecting the difference between 4 and 6. Draw the circumcircle to the pentagon by joining the point 5 equal to 5 to B or to A, and we draw the circumcircle to the figure that we target to draw, in this case a pentagon. Then pick line AB along the path and this one should come exactly at the center of the circle, so that we have our pentagon. Produce line AB. Remember that production of line in engineering drawing as well as mathematics really means elongating the line or extending it. So join the vertex at the center with point B and also with point A. and then proceed to draw parallel lines from vertices C and also from E that way. To get points F and G. F and G. Now, as I said earlier, this line joining A with D is parallel to the line EF, and DB is parallel to the line CG. When you join D and G, you get triangle, the triangle DFG, which is equal in area to the original pentagon. The original pentagon has, and the triangle are equal in area. So our second part of the journey is to draw a triangle, a rectangle equal in area to that existing triangle, which we have already gotten from our construction, and we know that it is equal in area to the existing pentagon. So in so doing now, remember that the area of a triangle is calculated by half base multiplied by height. So that half of FG multiplied by the perpendicular height from the base here to point D should be able to get us the area of that triangle. So how do we get the area of a rectangle equal in area to that triangle? By using the same concepts, we get half of that height, Remember that other initial line there was made for the purposes of establishing 5. So ensure that your line work are of top-notch quality so that you don't lose yourself in a quagmire of lines in your construction. So draw a line that bisects the altitude of the triangle there. Then erect a perpendicular from point F Let's remove the margin for now. This one can be done easily by creating an arc there and stepping off 3 times to draw a perpendicular from point F. This one, you can proceed to outline that because it's a final point. Similarly, erect a perpendicular from point G. Once again, draw an arc and proceed to have 3 steps, then bisect that resultant angle there and join it with this point G so that you have that perpendicular line. So proceed to outline that part, because that is the part of the rectangle that you are pursuing, and you can be able to see that this one is half of h. If h is the altitude of the triangle, then this is h over 2, because you have bisected, multiplied by fg, which is the same, and therefore the two areas are equal. The two areas are equal. Now, we had still to draw a square equal in area with that rectangle, which is equal in area with the triangle, which is equal in area to the pentagon. Now, and the steps are as follows. Produce then further the line FG that way. So we can mark the vertices of the rectangle as FGH, and then we can have I here, so that we look for a point J, and we get point J by getting a radius of equal to HG or GH to get this point J. Now bisect FJ. Bisect FJ. Bisect FJ. Sometimes when the line is too big, it might present challenges in bisecting it. But we can reduce it by creating an arc length, and we take a portion of that line off so that we bisect the difference, so that we can have that arc there from here to there. And we get the same result by bisecting the difference there. So the line that bisects FJ passes through this point FJ. So we can have this one, and we just call it K. So proceed to draw a semicircle with the center K and the radius FJ. You may complete the semicircle, but really you don't require the whole of the semicircle, because you require it in the zone closest to the right-hand side of the rectangle. Produce line GH. Produce the line GH to get a point L. Now, if our task, like we said earlier, is to draw a triangle, a rectangle, a square equal in area to the rectangle, which is described by vertices F, GH, IF, or FG, and HI. Those are the vertices. We are drawing a square equal in area to that. So the first part of the square, or the first line in the square, is GL. Therefore, from GL, we can proceed to draw the square by drawing an arc there to touch the line FG produced at point M. So M is also the second side of the square that we are pursuing. Therefore, from there, we can just create arcs there and proceed to complete the square. So that square is equal in area to that. We draw it in red for clarity. so that the required square is described by the vertices L, GL, and MN, or GM and L. Those are vertices. So the square is equal in area to the rectangle, which is equal in area to the triangle, which is equal in area to the pentagon. Once again, let's draw the rectangle in a different color so that it's clearer to the viewer. So the figures, we see pentagon, the areas of pentagon is equal to the area of the triangle, which is equal in area to the area of the rectangle, which is equal in area to the square. Let's attempt to prove that the area of the square and the triangle. Example. Use construction method. Use construction to draw a triangle of base length equal to 8 centimeters, height 8 centimeters, then that's A. B, construct a rectangle equal in area to the triangle. See, construct a square equal in area to both the triangle and rectangle. In A and B above. We should be able to know that area of the triangle is equal to half multiplied by 8 multiplied by 8, which is equal to that 2 centimeters squared. Centimeters squared. The area of rectangle then must be equal to, because since the height of the rectangle is h over 2, must be equal to 8 multiplied by 4, which means is that also that 2 centimeters squared. Area of square you can be able to calculate it by taking the possession of the rectangle with our line extended up and on the left hand side. And the reasoning here is simple, that when we bisect, if this one is 8, and this one is 4, then this one is 4, and a line bisecting 8 plus 4 will come to 12. It will come to 12 over 2, and that one will be 6. So it will come to around there, so that is the point X, which is a bisector. Now, when you take 6 here, it means then that the difference between point X and the head of the triangle, of the rectangle, which in earlier we said that this one is G and this one is H, so we can be able to pick them as were given, and this one is F, and this one is point J. We can be able to say that XG is equal to 2 centimeters. This one is 2 centimeters. We can also be able to say, since the point of generation for one side of the square is equal to the radius of the arc, so we can be able to say that this is 6 centimeters, because as our semicircle, this arc passes through a point here, so the difference between the head of the point of bisection K and that is equal to the radius of this semicircle, which is in this case equal to 6 centimeters. So we can get this point, which we said is L. We can be able to get GL. Then GL or XL, okay, GL squared B is equal to 6 squared minus 2 squared, which will be equal to the square root of that 2. Therefore, area of the square is equal to side squared. Therefore, it means it's the square root of root that 2 squared, which is equal to that 2 centimeters squared. And as you can see, it's equal to the area of the triangle, equal to the area of the rectangle, and equal to the area of the square. So thank you so much. And that is the end of that presentation. For the assignment, I want you learners to draw the pentagon, start from the pentagon of side 3.5 centimeters and go all the way to the square, and by construction, and prove that the same also is true by calculation. Thank you.